Good afternoon, everyone, and thank you for joining us today on our sixth RE Tech Talk. I'm Lakshmi Bohra, your host, and I welcome you all to today's talk where we will discuss waste to energy, biomethanation, and RE deployment process covering project financing, procurement of system, inspection, testing, and commissioning. We have successfully conducted 5 RE Tech Talks, which were organized as part of the collaboration between BEEP RE, a project on the integration of renewable energy in buildings implemented by IIEC and supported by Swiss Agency for Development and Corporation, SDC, and partnered with U Solar Clean Energy Solution. In this series, we have explored a variety of topics related to implementation of renewable energy technology in buildings with our expert speakers. The talks series began on 17 February and has successfully organized 6 webinars. However, if you were not able to attend, you can find the link of the recordings on your registered email on our YouTube channel. A quick recap on the last RE Tech Talk where we looked into the hybrid technology, solar and geothermal. Our speakers explained the working, technical specification related to geothermal system and business models for RE deployment. In today's talk, our expert will talk about the waste to energy biomethanation process and the RE deployment stages. Our goal is to give you essential knowledge and information about RE technologies and their application through our highly qualified speakers who are excited about imparting it to you. Before I invite our speakers, I would like to run you through the GoToWebinar interface we are using for these webinars. For the entire duration of the webinar, your microphones will be on mute and webcams will be turned off by default to avoid any accidental background disturbance. During the webinar, if you have any question or comment, please share the same using the question or chat options available in the panel at the right side of your screen. The questions will be taken after each session, so I request you to write your question in the chat box. You can also access the additional informative material in the handout section. Please note that this webinar is being recorded and the recordings will be made in the public domain. Thank you for your patience. Without holding you up any further, I will invite our first speaker, Mr. Anant Joshi, Project Manager, International Institute for Energy Conservation, IIEC, for sharing the opening remarks and setting the context for today's talk. A brief background on Anant. He has over more than 10 years of expertise and he has worked in the fields of clean air, electric cars, renewable energy, and energy efficiency. And he has also been part of the BEEP RE project from its inception. Anand, the mic is yours.
Thank you, Lakshmi. I welcome you all on the behalf of IIEC. I'll just give you a quick introduction about IIEC. International Institute for Energy Conservation is a non-profit, non-government organization. It was established to foster the implementation of renewable energy and energy efficiency in developing countries and economies in transition to enable economic and environmentally sustainable development. In India, we are registered at Section 25 company and we work as a charitable organization as well. We work across various sectors, but with common agenda of sustainable development and resource conservation. We have worked with government, private organizations, donors, multilaterals, and other several organizations. For today's discussion, I would highlight the project that we are doing with Swiss Agency for Development and Cooperation. The project is called BEEP RE, and they aim to develop a holistic solution for integration of renewable energy technologies in building sector in India. The program is almost 4 years old now, and we have achieved substantial outcomes in this project, working with different technologies and technology providers. We have created some lasting collaborations with public and private sector stakeholders during the course of the project, and we are trying to demonstrate the technical interventions in building sector related to integration of renewable energy in buildings. So without any further delay, I would request Lakshmi to invite our speakers for today's technical talk, and I think we will all be excited. We'll all be able to learn a lot about the biomethanation technology and other aspects
Rajesh has over 30 years of experience and has been working in GPS Renewables, a startup firm in waste management. His career has been in the into space and revolves around treatment and recycling of water, waste, and wastewater. Taken up after the presentation.
Hello. Can I start? Hello. 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 Can I get some information as to whether I'm audible? Hello.
You're audible, Rajesh, I think.
Yeah, okay. Can I? Okay, right. Thank you. Thanks, IIEC, for this opportunity to talk about biomechanization specifically and integration of the same into buildings. It's been a bit of a long association with IIEC so far. So what I'll go through some of the basics. There are essential differences between conventionally what people think of as renewable energy, because the first thing that people think of when they think RE is solar. Then it may be wind, they may be tidal, whatever. But this comes last, primarily for very basic reasons. So biomethanation as practiced is primarily looked at as a waste management solution, but the valuable output that comes out is a renewable fuel. So while it has been quite solar and other mechanical, electromechanical RE systems, are easy to understand, clean to install, and sort of doesn't require too many other parameters to be considered. Biomethanation, because it is intended for a different purpose, which is primarily solid waste management, did not get the kind of traction that other RE projects have had. So now what has happened differently recently has been that there are certain environmental factors that are coming to play. People understand the criticality of waste management. There are rules that are coming to force and being implemented. There are concerns regarding GHG emissions, global warming, and people understand methane is a major factor. And this is precisely what is generated by biogas. And if it's utilized in the manner that it's supposed to, that is to replace a fossil fuel, then you have significant impact that you can have on what is concerning the earth, or it's one of the major things that is happening. We won't call it it is the trend, but it's a trend that is moving heavily and positively in one direction, that is towards renewable fuel. The other factor that has played a part is that the cost of fossil fuels that biogas can replace have been skyrocketing due to various geopolitical factors, of course the obvious one being the Ukraine war. In addition to it, there is another product that comes from the biogas plant, which is the digestate, and that is, that's a manure which had not been considered officially as a manure till last year, when the government of India, to promote the biomethanation systems that are being implemented across India, has notified that it can be considered as a liquid fermented organic manure, and that it has to be utilized by any chemical fertilizer company, that some portion of organic manure has to be sold along with the inorganic fertilizers that are sold to their outlets. So these are the stuff that have sort of, okay. So what's biogas? Most of you know, this is just it's essentially a product of a biological process. So it is a way from waste, from different kinds of waste. So this becomes a green fuel. The other factors, the most important factor of this is normally the thumb rule that is followed, that 1 cubic meter of biogas that is generated through the process can replace half a kilo of LPG. So this immediately can has an impact in terms of cost. As the LPG price goes up, the value of biogas goes up. It's also a fact that it's a much cleaner fuel than all the other fuels that are used, because this essentially is methane, CH4. All the other fuels are C2, C3, C4, heavier fraction. So this is a much cleaner fuel to even burn, and it has its own positives and negatives because of that. Now, since we are talking about integration into buildings, what is ruled out in this specific one particular sector that is ruled out in this presentation are the agriculture and animal husbandry, which is a very large sector where biogas is actually utilized. So we've basically focused on the urban sector, which is the hospitality, the hospital sector, and the other sectors like industries, tech parks, and even municipalities and apartment complexes, where there is an intensity in terms of population. And when you have intensity in population, you have intensity in waste. It goes together. So we're basically focusing the thought process here, or the focus here is on understanding what kind of values or what kind of uses a biogas that is generated in a particular installation can be used. Now, this is just to show the varieties of systems. Unlike a windmill, which looks similar across, biogas comes in multiple formats. So this is probably one of the first things that people tend to have in mind. So I'm just showcasing a variety. In this, you can choose which is the most aesthetic one, and because I am presenting it, you would probably guess which is the GPS Renewables unit. To have a biogas system implemented in a building, there are a few factors that come into play. I'm here talking about greenfield installations. This is not something, the project is not something that you can ad hoc, tack on later. It can be done, but it's ideally done during the design stage. And assuming that some of you would be interested in from that stage itself, during the design stage, the quantum of waste that can be generated, organic waste that can be generated from a particular institution, needs to be addressed first. What are the possible options for utilization of biogas can be looked at? There is a specific area that can be that need to be allocated. Unlike you cannot hang it wherever is required. It can sometimes it's not allowed in basements. So there is some area allocation that's required. This also means that you have to understand what will be the access, what will be the use, because this is a product that needs to be utilized on a daily basis for it to generate the particular product that comes in. So there are operational access and ease of use that have to be considered. There is a supply of power and water that are required. And there is also the digestate utilization of disposal. These are the different points that anybody who's in the design phase need to consider if it is intended that biogas can need to be integrated into the building. Once it comes to implementation, this again needs to be pre-planned. That there is the understanding is that there will be, from the design stage as it goes to execution stage, There will be project management consultancies. There will be direct consultants that are involved. These have to be thought through. People who have experience in this need to be selected. There has to be, because there is integration between multiple components here. The framework of interaction between vendors who do civil, electrical, power, plumbing, finally who will put up the equipments that will utilize biogas, those had to be understood at the initial stage itself. There has to be a scope of work clarity, who does what, battery limits, all these need to be understood during the design and during the implementation phase. And also that there is a timeline that anything, this being an environmental product, fine, it is normally put at the last. But in few cases, the basic preparations like the civil works, the plumbing lines, they may have to be implemented in advance. So there are these requirements that need to be considered. So what are the applications that we are looking at? I'll just pass through a few, because what the reality is that right now the easiest use of biogas has been directly to replace LPG in cooking. It's a very common application. It's a very easy application. But wherever it's not possible, or where people want to look at another kind of use cases, that's what we're looking at. So there are two different varieties primarily. Because the moment you generate biogas, you have fuel in hand. Now it is up to you to decide whether you want to go for a heating application or you want to go for a power-based application. So when you go to thermal applications, which will primarily be better off because you're directly utilizing the heat, there are no losses in it, you will probably tend to get better returns when you go for a thermal application compared to any others. The last one that I mentioned, maybe in a few cases, the aesthetics and some lightings do come into play. It's something that you can always look at if the utilization in the original case is gas, the natural gas or LPG. So hot air generation. Now this comes to play in multiple areas, including hotels and hospitals primarily, because in a lot of large institutions, the integration of a laundry into the basic facilities are designed in. And most laundries utilize hot air, and most of the hot air in these cleaner environments tend to use LPG. So this is a specific area where utilization of biogas, partially or sometimes fully replacing the fossil fuel, is possible. In what we have to understand is that in a lot of these cases, generation of biogas itself is a technically challenging process. Utilization of biogas in an area where it is not initially designed for requires some amount of work between the various stakeholders, including the original equipment manufacturer who supplies the capital equipment. Most of them will have expertise in thermal engineering, and some modifications required can be done in advance if it is known that biogas is an option that the customer is looking for. That's quite important. So in a process air scenario, in industries also, it's possible to utilize it. And there, normally in industry, you will have a little bit more of leeway in utilizing and locating it, because aesthetics may play a secondary role compared to the hospital or hotel industry. I've just given some basic ideas as to what this intention is. If you look at the bottom right, there is mention of that much quantity of waste generated in situ can generate what quantity of air or water. So the second part is hot water generation. Again, similarly, these are hospitality industries that can utilize it. There are industries that can utilize it. And very interestingly, when people are using solar water heaters, when it comes to the times when this may not be available, a gas-fired water heater can be a supplementary product. In colder climes, it can be that hot water generated can be utilized for comfort cooling. So most of these applications are just it is being read out or listed out so that you have it in mind that if you are part of the design consideration nowadays, LEED certification or green buildings, these are the things that are trending up. So there are options other than the standard method variety of cooking that biogas plant can be utilized for. Okay, this is just you're utilizing it for hot water. You have, if you have more than a significant quantity of waste that is generated in-house, then the quantity of gas that is generated may be sufficient for even going up to a boiler and generate steam. So these kind of thumb rules that if starting from how much waste can be generated, you can have a thumb rule as to, okay, so much of biogas can be generated. This is the heat content that will be available. So designs can be, OEMs can be asked to supply equipments to utilize these quantum. It can be, most of these CapEx equipments are on working as well as standby mode. So there are definitely an option of having one of the units at least running fully or utilizing part of the biogas that is in operation. So these are just to give an idea as to what can be thought of during the design stage of a building. I'm not saying that this cannot be implemented later, but it will be much tougher because of space considerations, because of resource utilizations access to implement it at a later stage, although it is doable. A very simple system. This is actually comes under the waste management unit itself. There are incinerators in few states. These are not to be utilized at smaller scales. These are banned at certain areas, but there are definitely in a few cases incinerators are in use. And what more can you do in terms of recycling than utilize the waste, the energy generated from one waste stream to ensure that a second waste stream, which is hazardous, is incinerated by using a renewable fuel. So this is something that is utilized. In fact, there is a supply that we have done. Crematoriums are a case where already there are some systems in operation. So this is a very clear case in hospitals and wherever there is a requirement of hazardous or sanitary waste being disposed through an incinerator. This becomes a good option to go for. Of course, this is simple. This is what it is originally intended for. Where again, but integration of into cooking itself also requires a little bit of engineering. So if it is known at an initial stage itself that biogas is going to be utilized, the burners can be engineered suitably to ensure that there is a very smooth transition from a fossil fuel like LPG or PNG to a biogas system. Okay, the photographs I think are not showing. So this is what normally people come back and ask on a very regular basis: can we generate power? Power is the simplest thing to generate from a biogas unit. Earlier, maybe a few years back, there was not too many gensets that used to fire biogas. It used to be a modified diesel genset that were utilized, which had very low efficiency. Now, very clearly, there is an uptrend in availability of gensets, and this can be utilized in remote areas where you can have agro waste. But here, when you look at buildings, there are multiple methods by which you can generate a large quantity of biogas. It does not fall under the purview of this particular presentation, but it is possible to have power generated even in a good size industrial scenario or even a residential welfare society kind of scenario. And this combined with solar power can form grids where whenever there is an off for solar generation, the balance side, a few hours can be balanced with generating power through biogas. And then there is this, these are just examples. There are also cooling applications, there are heating applications that it can be utilized for. This is something that for combined heat and power is something that as a fuel in a turbine, this can be utilized. Right now, this is only available at scale at much higher capacities. There are micro turbines that are coming into play now, but not very significantly. So it made this particular combined heat and power may take some time to come up for building kind of scenario, but this is an option that definitely will come in once micro turbines and the associated auxiliary equipments for hot water and hot air generation comes into play. And then this is something which is off grid normally, because we see a lot of very high-end luxury hotels utilizing LPG or other fossil fuel just for aesthetic purpose. And this is a clear case where, if you do not want to utilize it in a different scenario in terms of either power because of the smaller availability or in terms of cooking because of whatever reasons, this is definitely an option that can be looked at. Then there are these biogas lights that are available, high quality ones still to come into the market, but this is an option that clearly comes in where in certain areas it can be both aesthetic and it can be as comes in the CSR initiatives. These are things that can be utilized by this. This could be in the future a good area where this can be utilized. But LED coming into play, high efficiency, we don't think on an ROI basis this will work. Only fossil fuel replacement works, but in other cases this is something that is doable. Then of course, just to touch upon the subject, for very large quantum of gas generated, which normally doesn't come into play in buildings, what is going to happen across India is generation of bio-CNG. Very large plants with very large input capacities can generate tons of bio-CNG, which can have a significant impact on our transition from fossil fuel to biofuels. Okay, and I hope I didn't overshoot. I hope I undershot the time. Thanks so much. Any questions that are there, either on a chat or on a separate note, I'll be able to. Thank you so much.
Yeah, thank you very much, Rajesh. It was a great presentation. There are a couple of questions by our attendees. First one of them is by Ramesh S. His question is, do you think biogas cooking would be more suitable when compared to solar cooker like the one recently introduced by Indian Oil?
See, this is essentially biogas is much as simple as cooking with LPG. That's what it is. Solar cooker is a little bit more technical, as I understand it. I may be wrong, but this biogas cooking replacing LPG or PNG has been standardized. We have had cases where commercial kitchen players have questioned the time that is required, and we had multiple cases where we have timed the cooking against conventional fossil fuels, and we have shown that it is possible to cook in the same amount of time. I'm not too sure whether this kind of usage or trials have happened in solar cooker, but anyway, I am not an authority, or I have not had a look at the solar cooker side, but this is the answer that I can personally give you, Ramesh. Thanks.
There is another question by Som Sukla Vishwas. Are there any safety clearances required for installing a biogas system?
Not in a regulatory manner, in an institutional setting, unless you have 5 tons of waste to be processed. So beneath that period, there are no regulatory concerns or no regulatory requirement. You have to inform them that this is being set up, but there are no such thing. If you store a quantity of gas which is more than what you utilize daily, then you will have some regulatory concern, but otherwise no. This does not come under PESO. The in-situ processing plant does not come under PESO. There is no other requirement in terms of clearances that had to be taken. Because you are generating and using gas as a process, you don't need explosive license certificate or anything. So there are no requirements for the kind of capacities that you're looking at. Bio-CNG plants, yeah, it's like an industry. So it requires every clearance that is there, but not in the quantum that you're looking at.
Okay. Rajesh, there is another question. Is there a minimum amount of organic waste output to make a system more technically feasible, or to make it more efficient? Is there a minimum amount of waste generation required?
See, you have biogas plants which are used in domestic for domestic purpose, half a kilo, 1 kilo. There are plants that are there. They are heavily over-designed, so they will tend to work. if you don't overfeed it because of feast and all that. When you come to the middle segment where you're looking at 100 kilos to maybe 1.5 to 2 tons, as the efficiency, this is unlike an electromechanical system. This is not depending on load. So it will be as efficient at 10% or even actually a little bit more efficient at 10% than it's at 100%. But it will not operate at 110%. So there are no efficiency drops across the range. That's the answer.
Okay, okay. There is another question. Any possible solution for urban cooking solutions?
Urban cooking solutions. Yeah, so that is where bio-CNG at large scale comes into play. It is pushed into cascades, and these are utilized in commercial kitchens. That is already an available technology. Mostly, it is utilized for CNG for mobility, but the same cascade is utilized in a few kitchens as a cooking medium. It's already there, but not on a domestic scale. It will happen because as you get the natural gas pipelines into the city, there is already as per policy, you can push bio-CNG into the pipeline. It's not yet implemented for various reasons, but at some point of time, you will actually be consuming bio-CNG through your natural PNG pipelines.
Okay. Rajesh, there is one last question. It's by Shaleen Mahajan. Biogas has been in there for about a decade. Could you see more innovation in this field compared to green hydrogen?
But biogas is not there for a decade. It's been there as gobar gas for maybe a century or more. So the only difference that has happened now is that the industry is trying to see how you can put it into the urban area, because rural, the quantities are mainly agro waste. Biogas has a good option is coming up in cities primarily because it's a waste processing unit and not because it's biogas, but because it's generated biogas, it has an additional application there. So in terms of innovation, the company that I am with is built from that particular scenario. We are just a 10-year-old company, and we have done a few innovations in biogas. We have 3 patents right now in the product that we supply, and we have 2 more patents for other kind of systems that we are into. There are other companies that we see who are focused on multiple innovations, either in a form factor, but yeah, it is coming up. The kind of waste that can be utilized, there are areas that research and development are being done. In fact, we are doing a few in that regard also. So there's definitely work that is being done. So if you want, you can go to our own website to see what kind of plant ours is compared to the conventional biogas plants. There's definitely innovation happening in feedstock, in terms of utilization, in terms of actual operation of the biogas plant itself.
There was another last question.
We are looking for people. Yeah, we are looking for people who are quite interested and have a background to do R&D. So that's something that I can share here.
Yes. There was another question. You mentioned in the presentation that the biogas system cannot be put in a basement, but a solid waste management system is typically in a basement. So is there a reason why we can't have a biogas system in the basement?
So, I mentioned it as a catch-all. See, there are various components to the biogas plant. The final part where gas storage is done, biogas is taken in a typical 1-ton plant of ours. In fact, we have digesters in the basement at a few locations. That's the entire system will not go inside the basement, because gas storage, there could be EHS regulations, there are safety considerations for whatever reason that the storage has to be outside. That part cannot be in the basement normally. So this is something that we look for even outside of India. In almost every case, they do not allow storage in the basement area. The other parts can come in, processing can be done, yes.
Okay, so the biogas production unit, the storage unit cannot be in the basement.
Correct.
Okay. I think these are all the questions that we got. Thank you, Rajesh, for such a great presentation. Now I would like to invite our next speaker, Mr. Sandipan Das, Business Manager, U Solar. Yes. Sandipan Das is a highly capable professional with a proven track record of effective communication, interpersonal skills, logical thinking, and analytical acumen in U Solar Clean Energy. Sandipan, we will be sharing the controls of the presentation with you. I urge everybody to have to write the questions in the chat box as seen in the previous presentation. Yes, the controls have been shared with you, Sandipan. You can continue now.
Just a second. Yeah. Okay. Thanks. First of all, thank you for this opportunity, and also thank you, Rajesh ji, for setting up the platform. Starting biogas and moving into solar, and understanding the perspective of more renewable options for the consumers in India. So today I will talk about project financing and procurement of the solar power plant system with inspection, testing, and commissioning, how the stages move forward. We have been talking about the solar power plant, what is the technical, how to do the technical evaluations, what are the parameters involved to set up a solar power plant. Today we will close the topic on solar power plant by going forward with this topic. So a brief introduction about USolar. USolar is a solar developer and EPC company based in Bangalore. So the company was incorporated in 2010 by Mr. K.R. Harinarayan, and gradually we started with the residential projects, and then gradually we moved into industrial and commercial segments. With a decade of experience, we have installed 170 plus megawatt of solar power plant across pan India and cater to 200 plus clients. So we offer project development under CapEx, OpEx, and group captive mode. We have our being an EPC company, we have a very strong engineering team. That is one of our USP, as well as asset management service, so that we can provide in-house service to our clients, which includes solar rooftop, ground mount, BIPV solutions, as building integrated storage solutions, as well as carports. Now, catering to our topics today. So once you have decided to go with a solar power plant and install a solar power plant at a facility, maybe on an RCC roof or a sheet roof, or maybe on the ground. Once the order has been placed, there is a certain process that any EPC company or a developer should follow, so that the quality has been maintained and they provide a very good service to their end consumer. So the first stage or the first phase of starting the process is called the detailed engineering phase. In the detailed engineering phase, design engineer and the dedicated project managers should visit the site, do a detailed analysis or detailed study of the facility, which will include to understand how the orientation and placement of the solar panels will be, because different buildings across the country we have seen has different orientation. It might be towards a true south, or maybe it will have an east-west orientation of the building. So accordingly, the panel should be placed so that the maximum generation can be optimized, or maximum generation can be get from the solar panels. So once that is been decided, or that has, the project managers and the design engineer has an idea of this will be the orientation of the panels, next happens is a structural stability. Especially in a sheet roof or in a ground mounted solar panels, it is very important to have a structural stability. In the sheet roof, the structure should be suitable enough to withstand the weight of the solar panels, because solar panels along with solar structures and other materials will weigh around 25 kg, so that for 1 kilowatt of system. So that stability should the structure should have to hold the solar plant. If we look into a ground-mounted solar panel, solar system, there how much of grounding of the solar structure has to be done below the ground level, and to set up the structure and build the plant. Next parameters that the detailed engineer should check is or will be checking will be the distance of the termination. Like for your LT panel room, how much distance, what is the meters, is it in meters or is it in kilometers, from the rooftop to the inverters and then to the LT panel, or from some cases it might be to the HT. And also they should do the panel room survey, understand the voltage level and spare feeder, presence of spare feeder or a bus bar to terminate the solar system. Once the detailed engineering phase is complete, now is the documentation procedure. So the detailed engineer will come back to the office and will do this documentation, which is not limited to uh, he or she will be doing the AutoCAD drawing of the solar power plant according to the orientation that has been decided, SketchUp for the shadow analysis, and PVSys for the generation check. Then the stat drawing to check the structural stability of the solar power plant, and a single line drawing diagram or SLD to showcase how the termination will be. AC/DC cabling, earthing drawings, earthing and how the earthing will be, how many earth pits will be considered to set up the earthing and lightning arrestor. That drawing has to be done. Walkaways drawing in case of the sheet roof, and a detailed BOQ. Technically, a solar, again, it's not limited to, but technically a solar power plant will have around 20 to 25 line items, and that detailed BOQ has to be implemented by the engineer that visits the site. These drawings are very important on the perspective that one part of the drawing goes to the client for signing off, for agreeing and discussions. Once that agreement has been reached between the client and the developer, these drawings now go to the local discom for the approval and NOC. So it depends upon state to state, but some state might require CEIG approval, some state might go with the local discom, but these drawings are very much required to get the commissioning of the solar power plant, that the discom will come and give an NOC that he has got no objection of setting up the solar power plant. Once the detailed engineering phase is complete, next comes a project management phase, which is another important management phase, because the setting of the solar power plant requires a proper planning, proper management on the perspective of the company as well as perspective of the client. So when a project manager receives the detailed BOQ, and once the detailed engineering phase completes and all this document is ready, that is then transferred to the project manager. So now project manager does the costing analysis of the detailed BOQ, the 20-25 line items. All the costing analysis is to be done. According to the after doing the costing analysis, he will prepare a project schedule and a Gantt chart. Because if he's not planning how to set up the solar power plant, then it might happen during the execution stage. There might be miss of certain stages or miss of certain costing, which might affect the financial of the project. Once the project schedule has been done and it's been discussed with the client, then the manpower planning happens. How many manpower to deploy to the site. Also, the ordering of the material starts from the same process. When the costing analysis has been complete, now the project manager will do the ordering of the material so that the time frame is being maintained and the solar plant is set up within a expected or committed timeline. Also, it is the duty of the project manager to do the risk mitigation and check out and list out all the safety procedures that the on-site team will take care of it. This is very important. This should be as per the HSE standard of the country. And risk mitigation is very important because there will be people who will be working at heights. And if there is some accidents happening at the site, then the project manager has to be liable for it. So to mitigate those accidents, to mitigate the risk mitigation has to be done by the project management team and the safety procedures, because these procedures has to be implemented same way at the site. Once this stage is complete, there is a deployment of manpower and safety officer at site. Safety officer will train the on-site people, the safety, and he will go through the risk mitigation done by the project manager, and then he will give the on-site training to the people on the site, so that there is a less accidents or there is no accidents happening at site. Also, after ordering of material, the project manager should do a equipment delivery schedule as per the Gantt chart he prepares, and he will supervise on the site and will check out and will make sure the government licensing happens on time, because because once the installation is complete, it is always better that the government licensing also happens parallelly, so that the time frame of the procuring the solar power plant gets reduced. So once the project managed, so these stages are complete, then the logistics happens. So all of the materials, if some of the materials is coming from the foreign countries, then that importing of materials, freight management, all the insurance regarding the delivery of the materials and the materials on the transit has to be taken care by the project manager. And like I said, there should be an equipment delivery schedule, and he makes sure that all the material reaches the site on time. Once the material reaches the site, so there are parallel work activities that get started. That is site preparation. So the site has to be prepared and ready and cleaned by the on-site project management team, so that once the material comes, it doesn't delay the procedure to set up the solar power plant, which includes the earthwork excavations, or this is for the ground mounted. If there is a earthing has to be done, so for that earthwork excavation has to be done. Backfilling, might be some land, if we are doing a ground mounted project, some land is not labeled, so that has to be labeled accordingly to the structural report, and the site will be ready. Also in the site preparations, marking of the structures has to be done, where the structures will be put up, the site foundations and marking has to be done. Once the site is prepared and good to go ahead, and some of the materials has already reached the site, then the civil engineering work starts. So the foundation for the module mounting structure, that the first step should be done according to the site marking, according to the site leveling, the foundation will start. Then the DC cable trays and the conduit will be spread across the solar PV yard, or through the roof, where the planning has been done in the design engineering state, that the cabling will go through that. So the DC cable and AC cable tray will be placed accordingly, and the foundation required for all the electrical systems, which will be including like the earthing, lightning arresters, all this civil and structural work will start, and also the module cleaning system as per the agreed agreement. So once civil work and foundation work is complete, then comes the electrical engineering work, where if there is a temporary cabling required, so sometimes while we execute a project, there might be some kind of power might be required for us to build a solar power plant, or might be drilling, or might be for some purpose, but power will be required. So temporary cabling setup will be done as per the requirement. And then the inverters, DC and AC and PV modules, how it will be placed, that planning has already been done, and that way the execution team will work. As per the cabling, the cable trays will be placed, and like I said, earthing and lightning protection system will be identified where to put, and will be prepared accordingly for the supply of the materials, and the materials can be put into that. So once this electrical and civil work gets complete, then comes a mechanical work where the modules, the inverters, the cables are laid, all the inverters get erected, modules get erected on the panels, and after all the wiring and fixing of the solar power plant with the inverters and is done, then we do the final testing and termination works. Once the testing and termination works is complete, there will be a final system check, and also quality process called quality inspection process will be checked, and then the handover procedure starts. In the meantime, the permission from the government comes forward. So after we have set up the solar power plant, solar modules, inverter structure, cables, earthing, now the final checkout. So while doing the final checkout, these are some of the highlighted portions, but it's not limited to, might differ from plant to plant basis. So it has to be made sure that all the equipments are in a disconnected or in a off positions. The installation that has been done on the ground level has to be checked with the design engineer documentations. All the conductors and the OCPDs all are disconnected and are sized properly, and there should not be mismatch of whatever the BOQ, detailed BOQ has been made and whatever has been implemented on the site. And the compliance with the local discom is met. This is very important. If the compliance is not made with the local discom, then there is a high chance that the local discom will not give permission to start the solar power plant. And all the termination screws and connections are securely tightened, and there are no loose connections, no loose nut bolts, so that in case of there is a wind speed, the modules do not fly away. So these are all the checks that has to be highlighted, has to be checked by the on-site project managers. Then it comes to, then after this step is done, while also doing the final check, it has to be make sure that the equipment is securely mounted. The racking system, the structures that has been built for the mounting of the inverters, mounting of the modules, they are securely placed and are not disconnected, and there is no loose wiring between them. Like for an RCC roof, we have to make sure before setting up the structure, waterproofing is done on the ballast space where the structure will be put, so that there is no leakage. This also we have to make sure in a sheet roof where we are drilling the roof to put the structures. We put the waterproofing so that there is no and it's properly sealed so that there is no leakage during the rainy season or any other point of time. And also the installations that has been carried out should always match as per the agreed terms between the client, whatever the build of materials that has been proposed, that has been agreed, might be the modules, inverter structures, it should match accordingly to it. And other safety items that has to be considered, that there should be an applicable warning signs, which is called LOTO, lockout, tagout. So these signs should be present and labels are posted appropriately near the inverter, near the panel room, so that we reduce the amount of accidents. And without someone supervising this, nobody handles this electrical equipment. After completing, we have to make sure that the site is very clean. There is no leftovers, there is no wire lying down, no nut bolts, because in this way we can prevent accidents. The documentation is complete, and all the attention has been paid to cleaning of the site, which is as per the HSE standard. So once the final checkout is complete, now we have the commissioning procedure. So the first step is connecting the power source to the system. So the AC/DC, the disconnect should remain in an off positions. We should check the fuses are not connected. So this has to be considered while connecting the power source to the system. Once that is done, the next step is to test the DC voltage. So these are some of the considerations that has to be taken care of, but this is not limited to. Like we have to make sure that the proper meter is set setting is for there for DC, and then after connecting the PV modules in series, and we have to measure and test it. What is the expected voltage from as per the detailed BOQ calculations of modules and as per the meter, and the voltage polarity, how much of difference is there on the voltage. So in this case also, we will consider the AC and DC disconnects need to remain in an off positions, fuses not connected as well, and watch for negative sign. So if there is a negative sign on the meter, that means that there is some loose connections or it is not wired properly, and we need to do that. So in the third stage, we'll do the AC voltage testing at the inverter output level. So we will make sure the proper meter is connected to the AC, and line to line test and line to neutral test has to be done. We have to compare the AC voltage according to the data sheet of the inverter. If inverter settings has more than one connection, there is multiple MPPT involved, multiple stringing will be involved. So we have to make sure that it matches the service setting. After this step, the fuses will be returned if applicable to the procedure. Now the startup procedure will be first to lift AC disconnect lever, that is inverter to grid should be started first. Then the PV to inverter should get started. So we have to consider this consideration, like the manufacturer manual for specific startup. So each of the inverters will have different manuals. That manual should be understand, so that we follow the whatever the specifications written on the manual, follow the same procedure. And most of the inverters, we have seen that there is a delay to check on grid and synchronization with the grid. So we have to make sure that we have to wait for some time so that we check that there is a synchronization with the grid. After the commissioning procedure, so after we complete these procedures, your plant is ready to commission, and it will start generating the solar power plant. So also, there are some of the safety practices that has to be maintained. As I said, it is one of the important parameters for a project management team when doing a project at a site, because we do not want any accidents to happen at site. So the work of the safety engineer or the safety manager who will be deployed at the site to make sure that he caters to the risk mitigation process that has been followed by the project manager. He gives training every day. There should be a daily training schedule, there should be a weekly training schedule, and there should be a monthly training schedule of the labors of the on-site project managers who are at site. All the permits, all the permissions required to set up the solar power plant has to be documented in a properly, and all the labors that has been working at the site should adhere to the labor rules or the labor laws of the country. So these are some of the things that we believe should be prohibited at sites, like putting on your headphone and walking at sites, hearing music at that time, smoking, and at that site, as we all know, there should not be any driving. You should not multitask at sites, like driver should not call at that time and do a site work or drive through that pass. Employees, so also when we do the safety or when we do a setting up of the solar power plant, we always do a medical check. And during the COVID time also, or after the COVID time, whatever the laws was laid by the country, that has been followed. So medical check, the labor or the safety man or whoever is at site should follow a standard medical procedure that he or she is fit to work at the site. There should not be firearms, and alcohol is not permitted at the site. Yeah. So this is the project. So I'll just touch over the project financing models at present in the as offered by USOL, also technically present in the country. So if you're looking for a distributed part of the solar power plant, if you're looking for a distributed part of the solar power plant, it might be rooftop or a ground mounted facility. You can avail three model, which is CapEx, that we all know, 100% investment by the client. The solar EPC player set up the solar power plant for you, and with a separate operation and maintenance contract, you can maintain the solar power plant for the next 25 years. There is an OPEX model. In the OPEX model, the client do not make any investment. The solar developer makes an investment, set up a solar power plant at your facility, and terminate at your LT panel. And there will be a minimum rate, which is much cheaper than the EB rate, and you pay that on a, as per the generation, you pay that on the rate. There will be a PPA signed between you and the solar developer. It might be for a long term or a short term. Short term PPA is not at present for a distributed type of solar. So long term PPA like a 15, 20 or 25 years. After the 25 years, the plant gets automatically transferred to you. Also, there is an EMI model. There are many banks. There are World Bank scheme happening at the country to promote renewable energy. So in that, you can avail the EMI model where the interest rate is lower. So you make a initial investment of 25 to 30% of the project cost, and the 75% can be availed as a loan for the bank. So there will be minimum interest rate, and the payback period maybe for the 5 to the EMI period maybe for 5 to 7 years. After that, you become the sole owner of the solar power plant. In new solar, we have connected to some of the NBFCs where we can connect you to if in case you're going for the solar power plant as a EMI model. And for this is for distributed. So in an off-site where the solar power plant is set up in somewhere outskirts of the state, there you can avail the group captive mode. Same, it's more or less same as the OPEX model, where you make an initial invest, though in the OPEX model you will not making any initial investment, but in a group captive mode you have to make a 26% equity investment by the client, and 51% of the energy should be drawn by you. This is as per the Electrical Regulatory Act. This helps, why group captive helps when setting up of a 10 or 20 megawatt of power plant, because this helps to mitigate the cross subsidy and surcharge that is there in every state. So when you're going for a group captive mode, you have to pay the solar tariff that will be decided by you and the developer. Apart from that, there will be billing and banking and transmission charges that you have to pay to the government, because you will be getting the power plant through the government grid. So thank you so much for the opportunities. If you have any questions, I'll be happy to take.
Thank you so much, Sandipan, for the presentation. It was very informative about the financing, especially. This brings us to the end of the talk. I would like to thank our speakers and everyone who attended and participated in this talk. You can find more information on our projects on our website and LinkedIn account for the same. This has been a great series, and we thank you all. Have a great day. Thank you.